Hi, in this video, I want to introduce the Excel spreadsheet for solving the retirement problem and also similar problems in this course. As in the previous discussion, we talked about the timeline of cash flows in the retirement problem. If you remember the details of this problem, we talked about the retirement plan for the next 60 years. And we have a regular withdrawal of retirement from year 30 to 60. So during year 30 and 60, we withdraw $50,000 from this retirement account. And also in this problem, we have this inheritance in the year 25. In year 25, you will receive $200,000 and add it to your retirement account. And also we target in year 50 to provide a gift to your daughter at $500,000. So in year 50, the retirement account want to provide $500,000 to outside. Okay, now let's convert this problem into the Excel spreadsheet. First, we want to have a small table to list the relevant parameters. Here in this problem, we have this retirement withdrawal starting from 30 years later, and the retirement withdrawal is $50,000. So we can write it down here. It is $50,000. Now I want to use this parameter to describe the strain of cash flow from these regular retirement withdrawals. In this Excel spreadsheet, the row 10 describes the time point of different years. The row 11 describes the cash flow of these regular retirement withdrawals. So starting from year 30, we will have this withdrawal of retirement account. So now I want to link the cell value of AG11 to the cell value of B2. So it will be $50,000 because I link these two cells together. Now I want to extend or replicate this calculation to the neighborhood cell. If I extend it here to the AH11, what will happen? Well, the cell value will be equal to the cell value of C2. We don't want this to happen. Let's make a change to the cell value of AG11. We want to insert the dollar symbol here. Then the cell value of this row will be anchored to the cell value of B2. Now if we replicate this calculation, or if we extend this calculation to the cell value of AH11, it will still be the cell value of B2. So now we can safely extend the calculation to the final period of this retirement account, that is 60 years later. Okay, so we finished the analysis for the regular retirement withdrawals. Now I want to do the same analysis for the inheritance cash flow. Let's go back to the original problem. In year 25, you will receive an inheritance of $200,000. So now we can type the parameter here. That is $200,000. Okay, and we want to go to the row 12 to type the cash flow there. So in year 25, the retirement account will receive an inheritance of $200,000. But here we have the opposite direction, so it will be minus the cell value of B3. Okay. No. Let's see. So it will be minus $200,000 in year 25. Now let's do the similar analysis to the gift. In year 50, you want to give your daughter $500,000. Let's write it down here. So it is $500,000. Now let's go to the row 13 to draw the timeline for this gift cash flow. We go to the time point of year 50, and we link the sale value of AZ13 to the sale value of B4. So now it is $500,000. Then we want to calculate the combined cash flows of these three streams of cash flows. We use the sum function in the Excel. You just list all the cells you want to do the sum calculation. So then it is 0. Now we want to extend the calculation to the neighborhood cell for this whole row. We extend this calculation to the year 60. Then we can say we have these combined cash flows at each year. Let's check the cash flow in the year 50. So in year 50, the retirement account need to provide $50,000 for the regular withdrawal and additional $500,000 as the gift. So in total, the retirement account will provide $550,000 to outside. So now we have a clear picture of the cash flows we want to target for this retirement account. Then we want to calculate the present value of these target cash flows. Remember, the discounting calculation has this equation. The discounting factor will be 1 over 1 plus real interest rate. Oh, we need to calculate the real interest rate. Let's wait. Okay, so in this problem, we have this nominal interest rate as 9%. And here we consider 0% inflation rate. What is the real interest rate? Remember the equation for the real interest rate. It is 1 plus the nominal interest rate over 1 plus the inflation rate. And then we minus 1 to calculate the percentage. It is 9%. So now we can use the real interest rate to calculate the time value of this cash flow. The present value factor for the cash flow in year 1 will be 1 over 1 plus real interest rate to the power of this period, year 1. So it is 0.9174. So in next year, we do the similar calculation. Remember, we need to verify we use the anchored value for the key parameters. Here we want to anchor the real interest rate value, and we want to change the period as the parameter. So then if we do this extended calculation for the cell value of D16, it will use the parameters from the cell B7, and it will change the cell value of D9 of C10 to D10. So then it is 0.8417. Now let's do the calculation extended to the end of the life cycle. We can do the extended calculation for the single row, or we can wait. Now let's say if we calculate the present value for the year 1, it will be the present value, it will be the cash flow multiplied by this present value factor. And we want both the cash flow and present value to change as the row extended. So then it will be 0 for the present value of period 1 cash flow. Similarly, for period 2, the present value of cash flow is 0. Now we want to do the extended calculation for the combined rows. We replicate this calculation to the year point 60. What do we find? We find at year 50, the present value factor is as small as 0.0134, and the present value of cash flow is $7,397. Now we want to calculate the total cash flow for row 18. The total cash flow will be the sum of this row C18 to row BJ18. So it is $22,248. Now I want to introduce the function in Excel spreadsheet. We go to the block of the formula block, and we can find the function symbol here. Then we have this search area for the function. Type the function we want to find. Click the go. Then you can see the payment function here. Click OK. Then we can say the interface of parameters we want to input. Here the discount rate is the real interest rate. The period will be a 30-period annuity. The present value we targeted is $22,248. Then we can calculate the payment to meet this targeted present value. It is $2,165.50. That is the exact amount we calculated in the online financial calculator.